Okay, so welcome back to the afternoon session of the first day of the PhD school. The second module or block will be given by Tamara Mchedlidze. I hope that many or most of you already know Tamara from other events, but Tamara is a professor at the University of Utrecht at this point. She did her PhD in Athens many years ago. We were postdoc colleagues in Karlsruhe for a while, and now she's been in the Netherlands for a while. And her talk will be kind of more on the bridge between theory and algorithms and applications of graph drawing and visualization. So visualization of opinion spaces, and we're very curious to learn more about that. Thanks, Tamara.
Martin, thank you very much for the introduction, and you managed to pronounce my second name. That makes me feel very good. Welcome, everyone. I know that you're probably now after lunch, so I'll try to make it as entertaining and as light as possible so that you don't fall asleep, in the middle of the session. So please feel free to interrupt me at any moment and ask your questions, because I will be switching from topic to topic. And if you wait with the questions until the very end, the questions may be off topic. Okay, so the title I have chosen for my talk is Visualization of Opinion Spaces from Theory to Application. However, one could argue for many different other titles, like Analysis and Visualization of High-Dimensional Data, or Visualization of Survey Data, or Opinion Polarization in Society and How to Confront it, or Metaphoric Maps, or The Hard Reality of Multidisciplinary Research Project, or maybe better, the fun of multidisciplinary research project. And when I say multidisciplinary, let me give you a little bit of understanding of where we are. So we will talk about data visualization and analysis, and not particularly graph visualization. It will be high-dimensional data. We'll talk about a little bit touch of how computational geometry is useful for us to construct those visualizations. We'll talk a little bit of human cognition and perception and how people form opinions on matters. And we'll talk about sociology, opinion formation, and polarization. So all of these topics, made it into this talk. That's why I'm saying hard reality, because when in this project, I constantly have to switch thinking about these different things. So let me start with the chapter 1 of my talk, and I will first talk about opinion spaces. So we want to understand the society, right? And let me ask you some questions that help us to understand society. So what is your stance towards gender equality? Or what do you think about environment protection? Or how much trust do you have to societal organizations such as government and media? And what are your moral principles? These are all questions that are answered by sociologists. And in order to answer these questions, they collect data by means of data surveys. And since these issues are complex, so none of these issues that I brought here can be answered by a single question, right? So in order to understand what is our stance towards gender equality, we have to answer quite some questions. And there's a few currently running studies around the globe that collecting this kind of data. And some of them are International Survey Program, World Value Survey, European Social Survey, European Value Study. This is only those I know and I have looked at, but there are much more. And all of these studies, they run like once a year, once in 2 years. They call this period waves. They run in waves. And usually every country has like a representative of maybe a few thousand people who answer those questions. So there's a sociologist group in every country around the globe that makes sure that the coverage is somehow representative. One more, which is a LIS panel. This is a super exciting data set because it's actually repetitive. So there's a mapping between the data points in the sense that it's the same people answering questions. So you really know how the data changed over time. For the other survey, it's not the case. So it's like 1 year could be one set of people, another year another set of people. So we don't have like mapping between the data points. Okay, so let's zoom in a little bit and look at one issue, for instance, the European Value Study, this survey here, which is a survey run by Tilburg University, Netherlands, just happens to be close to me, very convenient, and I can work with them. And so this European Value Study is a complex study of 200 questions about like everything from religion to family to moral principles. And some of these questions are about gender equality, and they look like that. So these sound like only 7 questions, not much, right? But for visualization, this is already a challenge. Yeah? So we have 7 questions, and they look like that. On the whole, men make better political leaders than women do. This is a statement, and then you have to assess this statement with the 4 possible answers. So this is like a Likert scale with excluded a neutral. So we don't have a neutral here. We have like strongly disagree, disagree, agree, strongly agree. They exclude the neutral to force a position. Yeah. You can read the other statements. University education is more important for a boy than a girl. You may ask me now why these statements are formulated in this particular way. Sociologists do their research, and they decided that this is the best way to formulate the questions to get objective answers. That's not something that concerns me. Okay, so imagine we get such a data survey field. What is the result of this is a 7-dimensional data set. Yeah? But this look like that. This is table with answers. So, what is the challenge overall? So, these data sets, they contain a lot of useful information about society, about people opinions, people values, people attitudes. And if you think about each of these topics that these data sets are covering, each of these topics is super polarizing. So, take gender equality is one example, but take, politics, take religion, any topics that is covered by these surveys are very, very polarizing. And on the other hand, if you think, what do we know about people's opinion on those topics, is very little. And we will see now how this information is generally communicated to the general public. It's also very limited. So let's have a look. Let's have a look how this information is making it to the world. And this is a specific project that has been developed by Tilburg University, so like a follow-up on the survey. So these visual maps allow people to go and see, what people think about certain issues. And in particular, this map is visualizing percentage of people that agree or strongly agree with the statement that man's job is to earn money and woman's job is to look after home and family. Yeah, and you can have a look. It's just a very fun map. Yeah, so you can realize something about Europe. Like you see a little bit east-west tendency. So. And you can see that this is not only one single question, so one single variable in that data set, but it's only two possible answers, agree and strongly agree. So we get idea on one question, but how people generally think about gender equality, we don't understand from that. Of course, you can go, they have like a drop down box, you can switch the question to a different question, and then see what people think there, and then another question separately. So you can try to figure out what people think on different questions, and maybe out of that make sense what people think in general, but kind of hard. Other examples, so percentage of people who consider tolerance and respect for other people one of the most important qualities to teach children. Yeah. So this is like the same map, and here they give also something like a timeline. How these changes in the importance of teaching children tolerance and respect changes over time in different countries. So here you see there are 2 variables and maybe even 3. So we have the timeline and we have the countries. So we have 3 variables shown, but only still one single variable which is showing the actual sociological issue. Here we have also another example of bringing this to the world. Here we have a percentage of environmentally conscious people versus the welfare. Yeah, so we see some kind of correlation between these two. And let's look now at a little bit more mainstream media. So this was a specifically designed web page to communicate this data. But what happens in media? Yeah, in media, it doesn't matter exactly what the data are. Here, for instance, is how much men are paid more than women, you know, just following the same topic, and different affiliations and in different industries. We see it communicated using a bar chart. Suicide events, again communicated in news, again communicated using a bar chart. So we actually don't really know what people really think behind it. We don't see the actual data points. Yeah, we only see summarized data in bar charts. Last 8 years have been the warmest on record. So here we see the years being above or below average, but we don't see again the temperature in different, you know, points over the globe. And yet another way, there are so many different ways, you know, but the visualizations which appear in media, they tend to be very, very summarized. That's what I want to tell you. Here's another way to visualize one variable is like, let's say, here we have abortion policies and access in the United States, and we have the states being colored according to their position. So these are and many other ways, but you know, whatever way web visualization you look in the media, most of the times it's very summarized. So we don't see the actual data points. So we have only one variable being visualized, and we have that visualizations are very summarized, and at the same time we see a lot of polarization on these topics. And so the question which comes up, you know, someone who studies visualization, is whether perhaps the way that we represent the data to the public actually contributes to the polarization on the topics. And there has been a little bit of studies, like it's an interesting question, like it's a huge question, right? However, there have been only a few studies trying to address that. It's not an easy question to address because you kind of need a realistic setup, right? And you need, you know, use visualization that people somehow understand. So this is one study where they looked at how showing possible election outcomes really influence people's decision on what to vote for. And they compared these three visualizations. So we have so a single dot here is a possible election outcome. And it's red if one person wins and blue if another person wins. And here they also include those blue-red points, which are like it's equal possibility that both win. And here we have like a mean value. So they compared these three, and they found that actually this visualization in the middle promotes the most trust to the results of visualization with a significant difference. And you know what they also conclude is that our qualitative analysis, our qualitative analysis uncovers the complex political and societal context of election-focused visualization, showcasing that visualization may provoke polarization. That's what they conclude. Here is another study which compares, closer to what I showed you before, just bar charts, yeah, with visualization with scatter plots, you know, swarm plots that show individual data points. And the data here are the wedges of the salaries of people, and the groups here are different races of people, so like white, Hispanic, black, and Asian. And what they also did, they tried to understand whether, when we look at this visualization, one or the other, we think more in terms of a group. So, for instance, these people maybe have less salary because they are less intelligent. So we attribute other qualities which are not explained by the data to the group, which visualization make us more biased and make us using our stereotypes more. And they found significant difference between these two. So when we see this visualization, we are more stereotyping than this visualization. So I find this super exciting because this is the only difference is the way we show the data, but we make the world much more black-white when we show that than this. Okay, so these are a few studies, and the same researchers, in these and yet a few papers, make it clear that very little is known how data visualization enhance stereotyping and promote opinion polarization, even on one-dimensional data. Yeah, so all these experiments I've showed you, they are all about, one-dimensional data. On societal issues such as gender equality, environment, that's just a complex issue. This is high-dimensional data. For instance, the gender equality in the European Value Study contains 7 questions. So we don't only, of course, when we show the data, we don't only want to show answers on each of 7 dimensions, but we want to reveal patterns in the data. So you understand the extent of the problem, right? So even by showing simple data, we already polarize people, but we actually have very complex data. And you will tell me, of course, data visualization has a lot of methods, maybe not a lot, but a few methods to visualize high-dimensional data. The thing is that most of these visualizations are very complex. People can understand bar chart, they can understand line plots, hardly. But when it's coming to high-dimensional data, it's very hard to communicate it to the public. And, at this point, I want to go to the second chapter and start talking about a visualization that could be a tool to communicate this complicated data to general public. So, if you have questions about the previous chapter, about high-dimensional data, societal issues, just maybe ask now, and then we go to the map-like visualizations. Okay. Okay, so map-like visualization. So this is a type of visualization that is very natural to us. Yeah, we already saw one of them. It's very easy to read because it's just geographic map. We know how to read it. And here in particular, color is used to show value of one variable. But there's so much more. So the whole area of cartographic visualization provides a lot of examples how maps can be used for visualizing data. So here, for instance, instead of coloring, we use just assigned values of the variables to the areas. And here, this is towards the huge area of cartograms. Here we have areas being distorted. So we have, I think, the world map, which is hard even to recognize, being distorted accordingly to the amount of earthquakes happening in the region. Yeah. So the regions are sized up or down depending on how many earthquakes are happening there. And here we have United States map also being resized according to, how much people vote either for one or the other candidate. These are very, very funny maps. Here we have that the boundary of the map is additionally simplified and either made into a low degree curve and either made to a concave or a convex curve depending on where the area have to grow or shrink. Here we have again United States and another kind of visualization idea is used. So every country becomes actually it's all based on tiny, mosaic cells, yeah, and then these mosaic cells are put next to each other to create the sizes that we actually need. So this gives a little bit more ordered view to the maps. So what I showed you until now is how the map size can be changed, like just a few examples. But maps can be changed also different ways. So researchers have used different ideas. So if you want to show not the variable that is about the area, but you want to show distances, you can use those zigzag lines and make the zigzag longer if the actually traveling distance between these 2 points is longer than the straight line. So by making these zigzag lines like smaller or more intense, you can show the traveling distance. So what I want to say is just with very, very few examples of many out there that we can do the following thing. So we can take the geographic map and with some additional data, and we can schematize it, by changing the sizes or maybe changing the distances visually, and we can come up with a map-like visualization. Yeah. So this is starting from the actual geographic map. But there is all other possibility to construct a map-like visualization is from abstract data. Yeah. So we can take an abstract data, and we can give it some positions to this abstract data, and then we can work a little bit on this to give it a map-like look, and we will end up with map-like visualization. So let me show you some of those map-like visualizations. So this has nothing to do with geography. Here we have mathematics in English Wikipedia. So we have different areas of mathematics. 2 areas of mathematics are close to each other if they are somehow similar or people have published in the 2 areas. And they are far away accordingly if they have little to do with each other. So these maps are also often called in literature conceptual or metaphoric maps, yeah, because they are metaphoric, or conceptual because they are not geographic in this sense. Here we have, again, a map of 22,000 abstracts submitted to a conference on Association of American Geographers. So we have different areas of geographic data analysis and how they relate. Here we have yet another beautiful visualization is a molecular network, and the metaphor is expanded, so we don't only have countries, but also have mountains, rivers, islands, and elevations, you see. And this is very relevant to this talk for the algorithm GMAP that constructs, particularly the TV land. So we have movies and actually series, I think, and 2 series are close if same people watch them. This is actually a network, so you can see maybe that there are actually edges behind them, and the edges indicate similarity. And more abstract now. So before we had like a really map-looking things, but you can get it more and more abstract. So for instance, here we have a stock uncertainty, yeah, but we have like the individual elements are just like bubbles, and bubbles are organized in countries. And whether this is perceived by people as maps or no, it's a whole question of research, right? So maps is something like a very stretchable notion. A little bit more, cartograph, Wikipedia articles, knowledge cartography. And if you like maps, then you can visit this online exhibition, Places and Spaces. There's so much more. Very nice maps. Okay, so why maps are actually interesting for me when I talk about opinion data? What we actually know about how people read maps. And in particular, what do we know about how people read these abstract maps, yeah, the conceptual or metaphoric maps? So researchers have compared maps to node link diagrams and to simple scatter plots. And what they have seen is that actually node link diagrams perform well across a few tasks. So these diagrams perform better. And the tasks are either concerning only nodes or node links or node links groups. And for all of these tasks, these maps perform actually better. So it's not surprising that these maps perform better for the node group, something like decide to which cluster the node belongs. So it's much easier to do here than here, because you have very little color. So like you have to think carefully, what color is it? Especially imagine like it's big. But they actually perform better for node-based tasks. So when you only have to say maybe how many nodes are in the group or something like that, they still perform better in this visualization. So there's yet another argument for using maps. Again, comparison of node link diagrams with maps. And here we see significant differences in the accuracy. Okay. So what the researchers actually did there, they asked kind of similar questions. Where nodes belong, how many nodes there are, if the nodes belong to the same group or not. Showing the visualization, and then they removed the visualization and then assessed what people remembered. And what they found out that people remember much better when they see this visualization. So with maps, people even remember better. And finally, there's a third study which compares maps with tree maps. There's another way of showing similar data. And here, what they have seen is that the accuracy on performance of stacks was highest for map-like visualization, followed by nested tree maps, and then by the non-nested tree maps. And the questions that were asked here was more of a type, which region is included in which other region. So if you see carefully here, there's other regions within this region, and that task was only a single task here. So we have a few studies, not that many, on metaphoric maps showing that maps can actually perform better. So here is like I stopped talking about metaphoric maps and I, in general, but I want to zoom in now and show you how to construct metaphoric maps. Give you a little bit of algorithmic idea. Any questions here? Online? No? Give me a second. Okay, so construction of metaphoric maps, maybe this is the most interesting for you, and this is just one of the many, really many possible ways, perhaps the simplest one. And I will particularly talk about constructing metaphoric maps for data survey, because that's what I'm interested in. So let's recall, like a data survey is a high-dimensional data set. And the values here are answers from strongly disagree to strongly agree. And what I do, I create a model, and I say that a single line is something which I call opinion. This is the way I answer questions. This is my opinion. And if I look at these two opinions, these opinions are totally, probably I won't. Sorry. Go back. I missed that. So if you look at these two opinions, they only differ here, and they differ here, which means that these two opinions are similar. And if I look at those opinions, yeah, so they differ a lot here, quite a lot here. You know, they keep differing like everywhere. So these are different opinions, yeah, or non-similar opinions. And now, if I think of how I would like to visualize opinions, if I visualize every opinion as a dot, yeah, then what I actually want that similar opinions are close to each other. Yeah, so the yellow and the pink should be close. The green and the blue should be close. But between the groups, they should be far apart, yeah, because they are dissimilar. And it's nice to mention here that what we actually use when we do that is the Gestalt principle of perception. Yeah? So when we enter the room and we see people, yeah, and people form two different groups, immediately without thinking we know that these people know each other, yeah, or we assume they know each other or they have something in common. And by using this Gestalt principle, we can actually use it for people understanding of visualizations. Okay, so what we actually just described now, what I described now, is taking high-dimensional data and using the idea of Gestalt principle, putting it in 2 dimensions, just on the plane, so that the distances are preserved. So if the distances in high dimensions are high, we want that the distances on the 2 dimensions are also high, and other way around. And there's a huge research out there in dimension reduction. So you take high-dimensional data and you project it on 2D in such a way that distances are preserved. And there are many, many different algorithms for doing that. And one of the methods which I like, it works for the data I have, and it's quite easy to work with, is called TSNE. So how many of you have heard about TSNE? A few of you. Okay, nice. So what TSNE is doing, I'm not going to go to really details. I have the QR code here. I think many people know much more about me than about TSNE, and it's really, really nice explanations out there, videos and everything. So if you want to understand TSNE, I actually recommend watching one of those videos, or even better, read the original paper. The original paper on TSNE is a very good example of how to write papers, like, let's say, algorithm engineering papers. Okay, so what TSNE is doing? It measures distance of opinion in high dimension, yeah, and it models it as probabilities, Pij, of opinion I and j being neighbors in high dimension. Then it models the probabilities Qij of points being close in 2 dimensions. So this is done using Gaussian, and this is done by using T distribution. And then they look at the divergence between these two, a special way to merge divergence between the distributions, and they try to change the position by changing the position of points. So how the position of points on 2D has to change so that this divergence is becoming as small as possible. Yeah, so that's the idea. And so we start from something like that, and after working with the algorithm, you get something like this. This is the data point. So it's a very, very first step in creating a metaphoric map. Yeah, or a map-like visualization. What we have just done, we have spatialized the high-dimensional data. That's the term geographers use. Yeah? So we spatialize the data. We give them positions on the plane. Okay, so many other dimension reduction methods, they're arguably better than TSNE, but I keep working with TSNE for now. The second step in creating the map is clustering. Now, forget about the spatialization. Forget about the 2 dimensions. We go back to the high dimension. We're still in high dimension. And what we want to do, we want to group the opinion in high dimension. We want to know which are similar, right? And before I showed you, the actual values, you have to know those are close and those are far away. And but we actually now have to find those groups. What are the groups in high-dimensional data? And one of the methods you can use is called method K-means, and it actually uses Euclidean distance between the data points. So you take the Euclidean distance between to measure the distance. And how does it work? So let me show the visualization better than describing. Yeah. So that's how it works. At some point, yeah, when these big points appear, first of all, this method wants to know how many clusters I want. So I want 3 clusters. And then it creates 3 centroids and throws them on the plane and randomly. And then assigns every point to the closest centroid. Yeah? And then it looks at the points assigned to the green cluster and says, oh, what is the mean value? What is the barycenter of that point? And then it reassigns the position of the centroid. It keeps doing that until the algorithm converges. That's very generally, yeah? Very simple algorithm, but that's the work in my case. More about K-means over there. Okay, so that's the second step. We did 2 things in high dimension. We did the clustering and we did the dimension reduction. And now we did the third ingredient. I imagine that the third ingredient is like this. This is where the computational geometry finally comes into play, and I love this moment. We need something which is called a Voronoi diagram. And I mean, how many of you know what is Voronoi diagram? Okay, nice. I don't have to define. A few don't know, so maybe I still have to define. Okay, so should I define Voronoi diagram? I should. Okay. Okay, so I want to partition the plane into cells so that every cell contains exactly 1 point. Yeah, and every point here, yeah, this point here is closer to this one than to any other point on the plane. Yeah, so that's the property of this partitioning. If I look at the cell, I look at any point here, then the representative of that cell is the closest point. I like calling it supermarket partitioning because it's very, very intuitive. Like if I live here, that's the supermarket I will go to. Yeah. Okay, and here's an intuitive way of understanding how a Voronoi diagram is constructed. Yeah, so you start drawing a circle, like a ball around a point, and at some point this ball starts fusing, yeah, start intersecting. When everything has intersected, you have your actual Voronoi diagram. This is not the actual way how a Voronoi diagram is constructed. We have an expert here to tell us. Yeah, usually Voronoi diagrams is constructed by a sweep line algorithm. Yeah. It makes the performance much better. Okay, so that's the third ingredient, and a little bit more about Voronoi diagram over there. And now we can look at the whole method of constructing metaphoric map. First of all, we start with high-dimensional data, and we apply dimension reduction. We get something like that. Independently, we apply clustering, and we get our data clustered. And then we combine. Yeah? So we color the points according to the clusters. And finally, we construct the Voronoi diagram, and we color every cell. So, you know, this is partitioned into cells. We color every cell into the color of the cluster, and we get a map. And let me now show questions. Yeah? One question that you could have. Why, for instance, do we apply clustering to high-dimensional data? We could also apply clustering to low-dimensional data.
Because we lose information. How do you decide on how many colors,
how many clusters?
How many clusters versus, I mean, in the dimension reduction, you get 1 point for each point in your original data.
Yes. So the problem is, you know, it starts from the data. And to decide how many clusters there are in a topic like gender equality, I have to talk to sociologists. So I do my cluster analysis. We will do that in the practical session. I do my cluster analysis, and then I see maybe there are 4 clusters, maybe 5, maybe 6. I don't care. Data don't show me. Then I go to sociologists, tell me how many clusters there should be. They know the issue. They have analyzed the data in different way, quality data, and they help me to figure out. Without them, I don't have a way. Okay, so there was an answer here. So why don't we do clustering low dimension? Because we lose data. I absolutely agree. But apparently, there are applications where it makes sense also to do clustering low dimension. So you already put the TSNE, you have your spatialization, and then you do the clustering. So you say, I believe the TSNE. Yeah? So it's like kind of 2 ways of looking at the problem. I say, I believe high-dimensional data, and I believe clustering, and then I try to impose that clustering on here. And the other way is to say, I believe the TSNE, and whatever clusters are shown here, let's show that. Yeah.
From your experience, if you look at this data, this combination of high-dimensional clustering and coloring really colors points that are close by in the dimension reduction in the same color. Is this in general?
No, it's not. It's not. It's really not. Oh yeah. Okay, I have to repeat the question. Yeah. Okay, so the question for the online participant, the question was, from the experience, what do we see? Do we see that the dimension reduction and the clustering algorithm kind of agree? And from the experience, I see that no, generally they don't agree. And the problem, the immediate problem, you will see problem just on the next slide. Let me give you the next slide.
The question is, do you want them to agree? Do you want them to agree somehow?
You will see immediately. You want them to agree because you want to present data as simple as possible to people.
Why you don't use clusters as additional dimensions?
Because I don't want to lose information that I have in high dimension. So I want to find a different way to make maps simpler. Not by losing the information, but yeah, that follows, okay? So let me, before I go to the next slide and you understand the issues of the disagreement between the 2 algorithms, the algorithm that I just presented to you is an algorithm called GMAP by Gansner, Hu, and Koburov. And with a small variation, the GMAP actually used a graph model. Yeah. So here I use just high-dimensional data. Yeah. And in case of GMAP, we have that instead of TSNE, we use graph drawing. So nodes become, my opinion become nodes. The distances between opinions become weighted edges. And then you can apply like a force-directed layout or, graph drawing algorithm of your convenience. And that becomes your dimension reduction method. So this component is different in my map implementation. Oops. Somehow it jumps back. Yeah, and there is yet another application that uses a lot this kind of diagram, and there these maps are called decision boundary maps. Yeah, this is in the area of machine learning. What they actually do, they take the high-dimensional data, they make maps out of them, and then they say, now I can quickly predict. So if I have new points, and new point is here, then it's actually in this cluster. And if I have a point here, that's actually in that cluster. That's kind of the decision boundary maps that their name is saying. They help me quickly to decide where the new data points should belong to which cluster. It's totally disjoint area. The same thing they call decision boundary maps. Okay, so now I'll show a real example, and you will quickly understand what are the problems of disagreement between the 2 algorithms. So for that, I've chosen a different subset of the European value study. Is a private morality, 7 questions. One of them, for instance, to what degree divorce can be justified. And we have 34,000 complete responses. So we need complete responses to work with the data. This is dimensionality reduction. This is clustering in high dimension and just colored. And this is the map. Yeah. And I think you immediately can see the problem, yeah, of disagreement between the two algorithms. So you see this green blob being scattered. You see the red dots being over here and there. Yeah. So that's the result of disagreement between the two. Yeah.
What's the light and dark colors in there? That's
What the light point?
What do the colors mean? The light are the points and the dark is are the Voronoi?
Yes. So the question for the online participants, what are the light points, what are the dark? The lights are the actual data points, and the darker is the region, the Voronoi diagram region. And of course, that's not the immediate result of what I told you. You know, if you just apply Voronoi diagram, these regions are infinite. Yeah, you have to cut them. And there are some tricks, you know, tricks like throwing random points here and there to cut off those regions, and you know, to make these boundaries more realistic, because they are not like that normally. They would be very straight, not really looking like map. So there are also random points thrown there to make those boundaries more looking like map-like. Some tricks. Okay, so here maybe we can talk a little bit more of why not to do clustering in low dimension. I think because this way we have more control and we can bring sociological research easier into this application. Yeah, so if sociologists tell us there are 4 clusters, yeah, then I should find a way to impose 4 clusters. I cannot allow my geometric algorithm looking at that. You know, imagine you do clustering here. What's going to happen? I mean, yes, there are some clusters, but there are much more than 4. You know, if you start clustering this data, it's like many clusters. Yeah, so we cannot control anymore. So in order to be able to bring this sociological knowledge from sociology, we have to impose 4 clusters. And of course, there's a lot of research that has been done on how to make those clusters connected. And I have worked on that myself, but that's not what I'm going to talk today about. If you want to ask me about that more. Okay, so I want to ask you one question. You know, this is a beautiful map, right? You know, looks cool, but is it useful at all? You know, even like I understand that this is a small size, we can print it on a huge paper, put it on the wall, but is it useful? You know, what are those clusters actually? How can we use that? Of course, you know, just by itself, it's quite useless. And what we need to do, we need somehow to give a possibility for the user to interact with this map and to understand what are the clusters, what are the data points, what are the groups of points, and so on. And one of the ways that we decided to go for is to build those histograms and the stacked bar charts. The stacked bar charts. So this stacked bar chart is for the green cluster. So you click on the green cluster, and we will do a little bit of. I'll show you the system, and you get this bar chart. But let me explain it. These are the questions of the survey, yeah, and these are the answers. And the parts, these segments of the bar chart show me how many people believe certain things. So these are the strongly agree. These are so the particular questions they had 10 possible answers. Yeah, so you see perhaps even 10 segments here. So this is the question 1, answer 1. This is answer 2. This is answer 3. From strongly agree to strongly disagree. Yeah, so maybe very few strongly agree, many strongly disagree. And this way, by clicking on the clusters, you can start making sense what the clusters are about, what people answer in the cluster actually. And once we had that, what we actually did, we gave this to sociologists and asked them to help us to interpret the clusters, accordingly to the knowledge they already have about those sociological aspects, yeah? And additionally, we asked them to give us names, because this is a pretty dangerous endeavor, to give names to those groups, because we may, bias people even more by those names. But of course, they try to be as neutral as possible, as close to the data as possible when describing the clusters, not use their stereotyped ideas about the clusters. For instance, if you look at the cluster tolerant, they also give us a description. But never mind. Let's go and see how the actual maps look like. I have this QR code. You can go and see yourself if you want to scan it. Yeah. Or I can zoom it in. And yep, so that's the web page with the maps. In the beginning, we are offered a tutorial, and I skip tutorial, and I go to the gender equality map. Something happened with the labels. They're hiding behind the points. So this is the gender equality map, and no, this is the environment map. Sorry. Okay, this is the gender equality map. And what I can do here, I can click on the cluster. I can look at the answers. And when I go over the questions, I see questions popping up. So for instance, this is the statement, university education is more important for a boy than a girl. It's a statement that we have seen before. And we see that 96% strongly disagree with this statement. Let's see at the statement which has all the answers possible. So this is the statement, when a mother works for a pay, the children suffer. Yeah, so that's a more debatable question. And here we have that in the cluster, super egalitarianist, something like 70% disagree, strongly disagree, and yet another 27% just disagree. Yeah, so by looking at that, even with the first glance, we see that most people really strongly disagree with the statements, and all statements are formulated in a way that somehow men are stronger than women, and you can immediately see that, that people who are like strong feminists. And you can look at the other cluster, which is egalitarianists. So again, we see that many people strongly disagree or disagree with statements, but not to that extreme extent. So that's the egalitarianist cluster. Then you can look at, let's say, family-oriented, and here we see that specifically these two questions, which has to do with the family balance, they have more people just disagreeing than strongly disagreeing. And so on, And additionally to labels, there are also descriptions. The sociology collaborators helped us to come up with the descriptions because sometimes people just want to read a bit about the cluster. Yeah. Okay, so that's the main thing with the maps. You can go and investigate them and see if you believe the map, if you believe the clusters. You really have a lot of information with these stacked bar charts about it. We haven't provided individual information on opinions, so somehow you cannot click an opinion, to see the actual opinion. That could be useful as well. So yeah, and the most interesting feature that this system also gives you is to go and fill in the questionnaire yourself. And if you are in the system, you can go fill in the questionnaire. I'm doing that randomly now. And then they say, show me the map. Sometimes it works, sometimes it doesn't. Yeah, I ended up being family-oriented. So the pin is also hiding behind the points. Somehow we can't bring it front. Yeah. And we have a different setup, which is designed for public spaces where you see the map on a big screen, and then there's a QR code, and then many people can scan the code and see themselves on the map. They put in a name, some name, and then we can see, like a group of people can see themselves on the map. Yeah.
As this is a lot about society, opinion building and opinion showing, how is the decision made which group does get which color?
Yes, very good question. Ideally, we use some neutral color palette and try not to reinforce people's stereotypes with colors additionally. So this is these colors are generated by the most distinguishable colors, for color-blinded people. By the way, if there's someone color-blinded here, you can tell me how well you can distinguish between the colors, how well those generators work. Okay, so this a bit more in the system, you can also filter a little bit. So, for instance, you can look at by countries, for instance, where the opinion collected in Germany lie, where opinions collected in Netherlands lie, maybe where in Georgia lie, like how opinions actually distribute in Europe. Birth range and birth year range and the gender. Yep, so that's what it is at the moment. And we can go back to the system. Of course, these maps now create so many different questions, and I want to look at the time. Okay, perfect. Yeah, so people do hold some opinions, about what others think about gender equality. And the first question is, can we use the maps to actually inform and convince people that things look perhaps differently than they thought? And can maps make people being more open-minded towards others who hold different opinions? Can maps actually challenge positions? So if you go, and you see yourself in the cluster non-egalitarianist, and then you try to figure out what people think in that cluster, and then, actually, perhaps, you start thinking, why actually in this cluster should I be in different clusters? So can maps actually challenge the actual opinion of people? Or maybe just inspire discussions on human values, and where this discussion leads. Can we perhaps be so bold that we think about a reduction of actual polarization of people on those topics? So there are many interesting, questions around application of those maps. What is the use of them? And here is the point where I want to give you a result of one experiment. Yeah.
Just one question to the map pictures.
Yeah.
If you would cluster the 2D data, would you then, like the dimension reduced data, would then every region be nicely connected and kind of nicely separated from the others?
Yeah. For the online participants, the question was if we cluster data in 2D, if the clusters would be connected. And the answer is yes, they would be connected. Yeah. So now I want to switch to the last chapter of my talk and talk about one application of these metaphoric maps and the actual experiment that we have done. And the experiment was done within the voting advice application area. And why voting advice application? I have to explain it. So the main, once we have developed the maps, we understood that what the actual use of them is to communicate the high-dimensional data to general public. And then you start thinking, what is the actual high-dimensional data which is already communicated to general public? Yeah, and then the voting advice application comes into play. Okay, so we want to somehow assess the effectiveness of these metaphoric maps, and the way to do that, we have to compare visualization A, the maps, to visualization B, on certain tasks. That's the way usually experiments in data visualization are set up, right? We have to assess effectiveness of visualization A by comparing some other visualization. And then, of course, we're challenged with the question, we can, I've been talking a lot about the bar charts, about line plots. But the bar charts and line plots are for visualizing low-dimensional data, one-dimensional, two-dimensional data, not seven-dimensional, yeah? And so we need a real world problem with high dimensions. Yeah? And the voting advice application is precisely one of those applications. And you probably know what voting advice applications are. Have you all used one? How many of you have used one? Not all of you have used voting advice applications. That's interesting. So voting advice application helps citizens to custom their vote before elections. And what happens actually is that you go to this webpage, voting advice application, and then you ask a number of questions, sometimes around 30, 40 questions of a type. More houses need to be built even if this comes at the cost of losing nature. And the answer is, again, liter scale, fully agree to fully disagree, sometimes excluding the neutral. And then the results are presented usually in this form. Yeah, that's the most common way to present results. So these are the parties, in particular these are Dutch parties, and then how well you match, yeah, based on the 40 answers you gave. Yeah, so parties have given answers, you gave answers, and then they do the match. They measure Euclidean distance mostly, and then say, okay, you match mostly to this party and that party, and then so on. But some applications, like Kiss Compass, is doing something bolder, which is very debatable, and they give you two axes, and you have here right, left, conservative, progressive, yeah, and then every party is positioned according to these two dimensions, yeah, and then they give your position. So here your position is here, for instance, yeah, and then you can use that map to try to assess where you lie better. So interesting with this map is that the way it is also kind of dimensionality reduction, but it's not done in an objective way, but it's done in a very subjective way. So what they actually do for every question in the survey, they give you points whether you have to go to the right or to the left, to progressive or to conservative. Yeah? So it's very hard-coded, the way dimensional reduction is done. But I say very debatable, because even if you talk with the second voting advice application in the Netherlands, is called ProDemos. They have this kind of visualization, and they hate it. They hate this one. They say this is very subjective. People misinterpret it, and you shouldn't do that. But it's the only one which we can compare to. So we say, okay, let's compare with this one. Let's use maps, try to use maps and compare them with this visualization, because this is a visualization of high-dimensional data. And when it comes to visualizing results of voting advice application, very little is known. There's been very few papers, one or two, that have studied those visualizations. This is one of them. But definitely they haven't considered scatter plots in maps. Okay, so that's how Kiss Compass looks like. That's how the maps look like. And instead of doing it here, I can go to the actual system and show you quickly. Okay, so this is Kiss Compass. You have already answered 40 questions before that. And these questions are grouped into issues. Yeah, so to every issue, some questions correspond. Yeah, and then you can switch on and off the issues and see yourself moving, hopefully. Yeah, you saw some movement? I tried to switch off and see if it takes quite some time. Everything is moving, because when you switch off the issue, parties also move. Parties move, you move. I think it's quite hard to make sense of it. Okay, so that's the initial condition, the Kiss Compass. That's the map. And the map is as close as possible to the European value maps. So what happens here, the light data points here are the answers of people on those 40 questions before previous elections. Yeah? So we ask Kiss Compass to give us the data, they collect data, and then we construct map out of that. Then we place parties on them, and then here we have the questions, the 40 questions. Yeah, so you can go and change your answer. What we actually figured, we understood by talking with Kiss Compass people, that people many times, they do the voting advice application once, and then they are not happy with their position, they start from scratch, and then see if they change their questions, where they end up. So they have to do the same thing many times and remember how they answered the question. So actually in our application, in European Value Maps, you already can change answers, and then you just say press, and then your position is getting updated. You saw a little bit movement, yeah? But here only, of course, my position is moving. Parties are not moving. Parties are there. Yeah, so these are the two conditions that we have actually compared. There will be a third condition coming up. I will explain why. Okay, so this is the control condition, which is Kiss Compass. This is the experimental condition with this map. And now you see that actually these two things differ in two things. Not only in visualization, but also in control. Yeah. See, here I control the questions. Yeah. Here I control the issues. Here map is reconstructed, there map is stable. So I can't really compare these two things. I mean, I can, but then I will not understand if there is a difference, whether the difference comes from visualization or from the control. Yeah. So in order to be able to understand where the difference comes, we construct a third condition, intermediate one, which is the visualization is the same exactly, but now you can control your position by answering questions again. Yeah. So by comparing these two, we understand whether the effect is because of the control, and by comparing these two, we understand whether the effect is because of the visualization. Okay, so and now, of course, you will ask me, and what are the variables? What are we measuring? By digging into vote advice application literature, which is quite huge, not about visualization, but general effect of voting advice application, we see that what they may influence is the vote choice. Yeah, apparent thing. Have your choice of a party changed after using voting advice application? And the second aspect, which is less pronounced, is the political knowledge. So after using voting advice application, has I learned anything new about the political landscape? That's the second aspect. And these are the exact research questions. I thought there was a research question written here, but somehow it vanished. And the research questions are, to what extent does the redesign affect the vote choice compared to traditional design? And the second question, to what extent does the redesign affect political knowledge? So these are quantitative evaluation. But we also wanted to do, we expected that we might not find anything in the quantitative evaluation in the precise statistical models. So we wanted to do something qualitative to get, ideas for future studies. And we asked something like, how do people interpret their position in the visualization? So we ask people a free question, how do you interpret your position? And then we wanted to understand also the usability and the enjoyment with the designs, because usability and enjoyment is important. And here are all the variables, and I can quickly go over them and explain you. So as I said, the main thing we want to investigate is the vote choice. Is the vote choice affected? And how we do that? We do that with a subjective measure. We ask them, is the vote choice affected? And there are two possibilities. There is effect, there is no effect, and there are four answers, actually. And the answers are, the voting advice application inspired doubt on choice. And the second, the voting advice application determined the vote choice. So we say that there is an effect if there is even a doubt introduced. And there is no effect if voting advice application did not affect the choice and voting advice application confirmed the choice. Yeah? So then there's no effect. That's about the vote choice. The second aspect we look at is the political knowledge. And the political knowledge can be divided in two groups. The factual knowledge, what I really know about political parties, and the perceived knowledge, which I think I know about political parties. Yeah? And for the factual knowledge, we ask people how well they understand parties' position. So I ask what these parties think about that question. Yeah? And I do that for 7 parties and 3 statements. And we have chosen the parties and statements so that they really differ, so that it's easier for people to distinguish. And then I measure the numbers of correct answers. And for the perceived knowledge, I just asked them, by using the application, I gained more understanding of the positions of political parties, yeah? And then give them fully agree, fully disagree. Okay, now the independent variables, something which we call propensity to vote. This word propensity is the first time I heard it in this political literature. I didn't know it before. Anyway, it is certainty during previous elections. The idea is that if I'm very certain, then whatever visualization is, my vote is not going to change. Yeah. So we have to measure somehow how certain people were, and we use previous elections for that. So during previous elections, I was sure whom to vote for. I was hesitating between few parties. I was hesitating between many parties, and I didn't vote. If we didn't vote, I think we exclude people from our evaluation. Okay, then the other variable, independent variable, is the opinion strength. Yeah. So if people have very strong opinions about matters, they strongly agree, they strongly disagree, most probably their vote choice is not going to change. Yeah. So that's why we included it as an independent variable as well. And we have fully agree, fully disagree is a strong position, and then these 3 are the weak positions. And finally, the design condition. And as I said, for the design condition, we have 3 different design conditions instead of 2 to figure out what effect is from, where effect is from. Finally, there's additional variables, the interpretation of the position. And we ask people, how do you describe your position on the map? This is an open question. We analyze it qualitatively, and then we do usability testing by applying the technology acceptance model. This is a standard way to assess usability of a system. Okay, so that's how the experiment looked like. I want to look at the time to know what I have. Yeah, that's how the experiment looked like. We asked their consent, we asked demographics, then we elicit their opinion. Yeah, so we ask their opinion on the 40 questions, the long part. Then we ask their propensity to vote, how sure they were in the previous elections. Then we randomly assign them to 3 conditions. Then we ask whether their vote choice has changed, their perceived knowledge. We do the open question of what is their position, how they interpret their position on the map, the ease of use, the factual knowledge, and then end. That's how experiments look like. And I can go through the results briefly. We did a pilot study, and through the pilot study, we corrected some wordings, changed a little bit of some design, small things. And we also were able to estimate the size of the sample we need to get statistical significance. Then we collected data through Prolific. This is a system that allows you to to find participants online. You pay them usually per minute, I think. And we have 382, 208 males and 172 female participants. And what happened with the vote choice? Okay, so for the vote, to understand the vote choice, we fitted a logistic regression model, which gives me a likelihood of changing vote given propensity to vote, opinion strength, and the design condition. And a little bit as expected, we found no evidence that the vote choice is meaningfully affected, and whether these 3 independent variables play any role in vote choice. which is very much in agreement with previous study about voting advice applications in general, not visualization in particular. Now about political knowledge. So let's look at political knowledge. And first, it is the factual knowledge. Here I want to show you a little bit more. These are so-called confidence intervals. And here we have the mean number of correct answers per condition. Yeah? And we compare the intermediate to control, yeah? The experimental to control, and the experimental to intermediate. So now if this confidence intervals contains 0, it means that with a high probability, there is no difference between the two conditions. So the only confidence interval that doesn't contain 0 is this one, which is experimental minus intermediate. Let me remind you. So these two seem to have difference with respect to factual knowledge. In which way? In the way that this provides more knowledge to people than this one. So, and because they only differ in visualization, we see that actually this provides people more knowledge than that one. Okay, but if we compare intermediate and control, yeah, intermediate control here, yeah, there's a slight evidence that intermediate is better than control, yeah, but the confidence interval contains 0, so we cannot really be sure. Now about the perceived knowledge, we have a very similar effect. Again, this condition is better than that with respect to perceived knowledge. Okay, so regarding the ease of use, we have the 6 questions, the standard model for assessing the ease of use of all conditions, the mean value of them. And again, we look at the difference. And we again see that intermediate scores better than experimental. And then we also see that the intermediate scores better than control. Yeah. So we actually found out that if you take the current case compass but change the control and give possibility to people to switch questions, you get a better voting advice application. Yeah. We haven't managed to prove that showing people opinions of other people and all this complexity of the map actually helps people. It seems that it harms people to gain more knowledge, political knowledge, and it's definitely less usable. Yeah, so the control mechanisms make case compass more usable, and map shows lower usability than access. But there's something interesting there, it wasn't for nothing. Our hope for maps, like when you like some visualization, you believe in it, you definitely want to show that it has a point. But it's apparently in this experiment we haven't managed. However, when we looked at the open question, interpretation of the position on the map, we found something interesting. So we did this standard way of analyzing qualitative data. We tagged sentences and phrases using these 4 tags, in particular subjective tags, where people talked about something ideological, something left, right, progressive, conservative in these terms, or we tagged it with parties, maps, region, opinion match, with more objective descriptions. When they talked about I'm similar to the party, I'm in this region of the map, my opinion match with something. And what we see, this is the control condition, this is intermediate, this is experiment. So we only look at the percentages, no statistical differences or anything. But we see an interesting thing, is that when you look at the control in intermediate and experimental with respect to the ideological, you see that there's fewest ideological mentions in the experimental condition. Yeah? So people think less here in terms of I'm left, I'm right, I'm progressive, I'm conservative, but at the same time, they think more these 2 blue bars are higher than here and here, which are maps, region, and opinion match. Yeah, so they talk more about being close to the parties, being matching, having a matching opinion to the party. So more of an objective terms. So what our conclusion is from this is that it's very possible that map is interpreted in a more objective way than actually KISS compass is, the two axes is. And that, of course, will be the subject of the next study. So maybe before I give thanks to many people, I want to ask you if you have questions. Go to the previous slide. If you have any questions here. Yep.
Maybe also going back to
I won't hear you. I have to come close. I can repeat. Just yeah.
Thanks. So maybe going back to the motivation you mentioned, or part of the motivation you mentioned introductorily, of visualizing information in a more non-biasing way, maybe. I think one information that I don't see incorporated to in comparison to like other visualizations that you show is how many people have a certain opinion. Do you have any ideas on how to incorporate that, or is that just something different that you can't really see in those?
No, absolutely. So Olen, people have heard, yeah?
Yes.
Yeah, okay. Absolutely. So the map actually gives me an easy way to show how many people have certain opinions, right? So if the region would be sized accordingly to the number of people in it, then map would be also a way to communicate the amount of people holding opinions. But apparently it's not. This heuristic way doesn't give me. And that's why this is one of the questions that I'm currently working on. There are already algorithms that, of course, all the cartograms gives you ways to resize, but then you don't have individual data points. So now, like, the next algorithm question is how to incorporate dimension reduction and map production and do it at the same time. So that's something I'm currently doing. So perfect question. Thank you. Yeah. So, the question? No more questions? And I want to take a chance and give thanks to these people, but also to many other people who have contributed, because during this research I've talked to so many sociologists, political scientists, and people in industry, and many different people who have even the people in the media, who are interested in using maps and showing them in newspapers. So Isabel Flo is the main developer, and she took over the project, the Map Chaps, which was just a student project. We have a very interesting student project, software project. Instead of a bachelor thesis, 10 students work on the project for 6 months. And they actually developed the European value maps, and then Isabel Flo took over and made it perfect, divided. Inge Zibman, Quita Maus, and Tim Reskens are researchers in Tilburg University, and I talk with them regarding the sociological aspects. Gregor Betz is a colleague in Karlsruhe, and he is a philosopher of science, argumentation scientist, and he is the one who came up with this whole idea, actually. So back then we worked on different data, different maps, and then he said, oh, maybe you can actually visualize sociological data. He's not currently in the project, but I'm always very thankful to him, because he actually came up with the question. And Damon Verboom did this sociological study that I have described to you. He is a master's student who has finished. He got excellent grade because it was a very, very complex study to achieve on his own. And so this is visualization and graphics group I'm currently in, with all the expertise on dimension reduction and how do the user studies. I'm constantly talking to them. So that's the people I'm talking to. And just for an inspiration, we have a few more. No, we have no time, but as an inspiration to see how that have looked like already a long time ago in Karlsruhe. There's a media museum, and we had this beautiful exhibition with different data. Back then it was network data. with Gregor, and people could go to the iPad here and fill in their opinion and see themselves on the map. So that's how I imagine these maps being deployed all over, in public spaces, and provoking discussion on social aspects. Yep. So we have a break now of half an hour, and then we are back to do some tasks. These are the 3 types of tasks that we will be working on, but that's in half an hour.